Day once again, grade 12s, and welcome back to the anti-science theory. So, on the past two videos, we had looked at the introduction to vertical projectile motion. We've also looked at the diagrammatic interpretations of the vertical projectile motion. So, in this video, I just wanted to do a question, and I think I got this question. I sourced this question from the DBE. Um, 2024 June exam. Yes. So this one was from the DBE 2024 June exam. I don't know why I keep speaking like that. Okay. Right. So they say to us that a learner is standing at the bottom of a building. Right. So there's a learner here standing at the bottom of a building, and that learner basically throws the ball vertically upwards, right, at a certain speed of 11 meters per second, and ball A reaches a maximum height of t. After 0.72 seconds, another learner standing on the roof throws ball B upwards. The two balls reach point T at the same time. Right. So, first and foremost, I always want to recommend you guys, before you answer these questions, always have your own personal diagram on the side. Trust me, that diagram will be very helpful. Very, very helpful to you guys. Believe me when I say that. Right, so I'm going to do is I'm going to have my diagram on the side, right? So I'm going to have my own diagram here. One diagram that I can understand as a person who's answering these questions, right? It must be something that works for you. So this is me having my diagram here. Nothing has changed, nothing is different. I still have the height of the building being the height h. Okay, and I still have the ball B right there. Let me just put B in the ball. So I have the ball B and I have the ball A. So they say ball B is thrown vertically upwards, and then I have a height here. That height is going to be the height T, right? So that's the height at that point there. We have the height T, right? Cool. And then I think that's just about everything, right? So what do I know? I know that my ball B must go up, reach the maximum height, and then eventually come down. Although we were not told that it came down, but we all know that it comes down eventually, right? And then I know the same thing applies for A. So my A must go up and then come down. Right. Cool. We are then going to need to apply the knowledge that we had in our previous videos. So we know that I'm going to call the point from where ball B started, I'm going to call it point X. The maximum height at point T, we're going to call it point Y. And we're going to call the point in the same height as X, we're going to call that point Z. And then the height on the ground, we're going to call it point P, right? Cool. Okay, now I can start answering the questions. But before I do that, remember, we must choose a direction. So this is me in the exam. I am sticking to my direction and I'm choosing upwards as positive, and automatically anything downwards must be negative, right? Now I can start answering the questions. Then they say to me, what is the difference between free fall and projectile motion? That is the first question. Remember, free fall is the motion of an object under the influence of gravitational force only. And then projectile is what? Is an object that undergoes, it's an object that undergoes free fall. That is, it is an object that is given an initial velocity and moves under the influence of gravitational force only, right? Cool. And then now I can start answering my question. So 4.2.1, they say to me, calculate the time taken by A to reach the maximum height at T. Aha, so my main focus is on A. So what I like to do is I like to collect all my necessary information to summarize it. Why does this help? It helps so that I don't always have to look back at the statement, right? So I'm going to say my data. I'm going to call this my data, right? So my data is going to be for ball A. Remember, I'm trying to calculate some information for ball A. Now I want information for ball A from when it started from the ground all the way to the height at T, right? So we start there. What is the initial velocity of ball A? Well, I know that the initial velocity of A was given to me in the statement right over there. They say the ball A is thrown vertically upwards at 11 meters per second, right? So I know that's going to be 11 meters per second. Okay. Is it positive or negative? It's positive. Why? Because I chose upwards as positive, and they did say that it was thrown vertically upwards, right? And then they say ball A reaches a maximum height of T. Okay. Right. And then they say in the question, I want the time taken for A to reach the height at T. So that means I want my delta T. Do I have my delta T? No, it is what I want. But what do I know about the point T? I know that the point T is also, please notice, it is also the maximum height. I hope you guys can also see that at point T, I also have my maximum height. So what do I know about my maximum height? I know that at my maximum height, the final velocity is 0. Remember, if you don't know this, please make sure that you have watched 2 of the past videos. Cool. So I can then say the final velocity at T is 0 meters per second. Okay. From here, I know that the value of A, which is my gravitational acceleration. Now, quick question. Do you think A will be a positive or a negative? Think about it. I'm going to give you a few seconds. If you said A is going to be a positive, you have made a mistake right there. But it's okay. We're here to make sure that we make mistakes and we fix them. Remember that the value of A always acts down, meaning if I choose up as positive, anything down must be negative. That is why we're going to have a negative 9.8 meters per second squared. It's a very important point. Very, very important. So now from the equations of motion, I know that I can then use the equation Vf equals to V initial plus A delta T. And then from there, the initial velocity we said was 0. The final velocity was 0. The initial was a positive 11 plus my A of negative 9.8 times delta T, right? And I know that I can have negative 11 here equals to a negative 9.8 times delta T. And if I divide both sides by 9.8, divide both sides by 9.8, I get my value of delta T as exactly, let me get my calculator. So delta T will be 11 divided by 9.8. That gives me a value of 1.12 seconds. Right. Rounded to 2 decimals, by the way. And there you have it. That is the time it takes A to reach the point T. And then again, we move on. They then say to us, calculate the initial velocity of ball B. So that's 4.2.2. So they want the initial velocity of ball B. So how do we do that? So think about it. So for ball B, we don't have the initial velocity, but we have the final velocity as it reached the height T, right? Remember. So we know that I'm going to now collect data for ball B, right? For ball B. And this will be data from, we're going to be taking our letters from X to Y, right? So that's what I'm going to do. I'm going to take data from X to Y for ball B, right? Remember, we used our letters there on the side for the motion of B. That means I'm taking from the height of the roof to the maximum height T. What else do we know? So we know if that's the case, then I need to have something like this. The final velocity must obviously be 0 meters per second because at point Y, we also have point T, which is the maximum height, right? The initial velocity is what I am trying to calculate, so it's unknown. Do I have the value of A? Yes, I know that A is a negative 9.8. Remember, it does not change once you have established a positive direction, A is affected by that direction and it stays the way it is from the beginning until the end of all your questions. Do not decide to change your direction mid-question. Please do not do that. Once you are in the middle of you answering your questions, don't just decide to change your direction. Stick to your original direction at all times. So in this case, I have my final velocity as 0, my initial velocity is unknown, my A is negative 9.8. But then again, do I have the height from X to Y? Well, the height from X to Y is what I do not know, right? But now, if I want the initial velocity of ball B, then I also need to remember that I was given crucial information. I was told that 0.72 seconds later, ball B was thrown upwards. So 0.2 seconds after A was thrown, ball B was then thrown. That means, now check something. The time for ball B, we're going to call this delta T for B, must be equal to the time for ball A minus 0.72 seconds. That's because of the fact that after 0.72 seconds, ball B was then thrown, right? Meaning the time difference between A going up and B going up was 0.72 seconds. Cool. And then now that we want the initial velocity, can we try to get something? Yes. Now remember that we had already calculated the time for the time for ball A to reach the maximum height. So let me be specific in my answer. So that's 1.12 seconds until point T. So we had calculated that time. So that was the time for ball A, right? So I'm going to use that time to get the time for B. That is, from here, I am then going to say this will then be 1.12 seconds minus 0.72, and that will then give me a value. Let's see. So 1.12 minus 0.72, that gives me a value of 0.4 seconds for ball B. So that's the time for B, right? Cool. And then now, let's go to our question. We are still required to calculate the initial velocity of B. Now we need to look at our given information and say, okay, do we have delta Y? No, not in this case. Delta Y is unknown, right? Which one is delta Y for point B? If we are looking at X to Y, then you notice that delta Y would be the height from where? From the roof of the building all the way to the maximum height. That's what delta Y would be, right? Okay, cool. We don't know what that is, but now we want the initial velocity. From the information that we have already acquired, what can we do with that information to get the initial velocity? Well, what we can do is to say the final velocity equals to the initial velocity plus a delta t. Now remember that the final velocity is 0, right? And the initial velocity is what I actually want. However, my A was negative 9.8 and my time was 0.4 seconds. So this means that I'm going to say negative VI, I transpose the velocity to that side, equals to a negative, let me see, what's 0.4 times 9.8? I get a value of 3.92. Therefore, the initial velocity of ball A was 3.92 meters. Wait, did they say the speed? Oh, the velocity. Cool. So it's 3.92 meters per second upwards. Now, what do you notice? You notice that you ended up with a positive value. That positive value confirms that ball B was indeed moving upwards. So this was for ball B. Right, and there you have it. I really hope that was very clear. This was a very nice question, and this should have been a typical 3 to 4 mark question. So what does the last question actually say? So the last question then says to us, calculate the height age of the building. So they want the height age. They basically want us to calculate this guy right here, right? So now, how can we go about doing this? Now, I want you to think about it. What I can do is I can try to determine the height of B from the roof of the building all the way to the height T. And we're going to call that our delta Y for B, right? We're going to call it that. And then I can then say, what was the height from the ground all the way to the point T, which is the maximum height, right? Then from there I can say, notice something. I'm not sure if you guys would see this, but from there I can then say, right, this is 4.1.3. From there I can then say, okay, I can then say that the height of T must be equal to the height H plus delta Y for B. Notice something. Remember that height T is the total height from the ground, and it consists of exactly height H plus delta Y, right? Because it's this portion here at the bottom, which is the height of H, plus the portion at the top, which is delta Y of B. I hope you guys can see that. So that is why I said delta T, which is the total height, equals to the height of H, which is what I want, which will then be H plus delta Y of B. And if I decide to make H the subject of the formula, I get the fact that H is going to be T minus the delta Y of B. So I'm going to be working according to this equation here. Now I need to start collecting my data. So I'm going to collect my data for both ball A and ball B. So I'm going to have ball A on this side and I'm going to have ball B on this side, right? So for ball A, what's the initial velocity? Remember, the initial velocity of A was a positive 11, and the initial velocity for B was calculated in the previous question as 3.92. So that's 3.92 meters per second. This is 11 meters per second. Right. And then from here, I can then say, okay, what is the final velocity of A at the point T? The final velocity at T is 0. Similarly, the final velocity for B at T is also 0. Remember that T is the maximum height, where we know that at the maximum height, the final velocity is 0. And then again, we then say, cool. What then can we say about the time? We know that it takes the time the time for ball A, we're going to call that delta T for A, to reach the height T is 1.12 seconds. And then we calculated that delta T for ball B was exactly 0.4 seconds. That's the time it took B to reach the point T. Okay, now we want the height. So that is, if I need to determine delta Y for A, I then need to say delta Y for A. So let's just say delta Y for A is, well, T. Let's just call it T, because if you think about it, A is from the ground all the way to T. So it's basically the entire height of the point T. Notice something, it's from the ground all the way to the point T. That is why I say it's better if we just call the height of A as T. So we're going to say T is going to be equal to an unknown value. And then for B, we're also going to say that for B, delta Y of B is unknown. Right, so we then need to start by getting the value of T using the information for the ball A. So we're going to say VF squared, right? I think that's the best equation we can use at this point. We're going to say that's going to be VF squared. This is calculations for the ball A. VF squared will be equal to the initial velocity squared plus 2A delta Y. So initial velocity squared is 0 squared, which is the final velocity is 0, the initial velocity is 11, we square that, plus 2 times negative 9.8, remember that's my gravitational acceleration, and delta Y we said was T. And then we're going to say 11 squared is 121, right? So if I transpose it, I'm going to get a negative 121. That's going to be equal to a negative 19.6 times T. If I divide both sides, I get negative 19.6 divided by negative 19.6, zip, zap. I get my value of T as exactly 121 divided by 19.6, which gives me a value of 6.17 meters. Right, so that's 6.17 meters. Okay, that's the point, that's the height of the point T, right? And then now I need to get that for B. So I'm going to use calculations for ball B now. So I'm going to say for ball B, once again, VF squared equals to VI squared plus 2A delta Y. And then we're going to say that VF squared is 0, right? And our initial is 3.92 squared plus 2 times negative 9.8. And then our delta Y will then be delta Y of B. And then from here, we say 3.92 squared gives me a value of 15.336. When I transpose it, I get negative 15.3664 is then equal to negative 19.6 delta Y B. And if I divide both sides by negative 19.6, divide both sides by negative 19.6, I will then have a value of exactly, so delta Y for B will be that 15.3664 divided by 19.6. That gives me a value of 0.784 meters, right? And there you have it. Cool. And I want you guys to notice something very important. I'm not sure if you guys have picked that up. Notice how for the value of T, I got a positive value, and for the value of B, of delta YB, I got a positive value. Why is that? Remember, if you had chosen up as positive, that means anything that includes the upward motion of the ball must also be positive. So point T is the height reached by A while A was going up. Hence, you have a positive value. Once again, point T is also the height reached by B while B was going up. That is why you have a positive value. Right. Cool. So from here, I will then say, going back to my equation, remember I had set up my little equation right here. So I'm going to take it and I'm going to bring it down. Okay. Right there. So I'm going to say, going back to my equation, I can then say that my height will then be equal to, what's my value of T? That's 6.17 minus 0.784. That should give me a value of 6.17 minus 0.784 minus 0.784 gives me a value of 5.386 meters. And that is our height H. Right, ladies and gentlemen, I really hope that was very fun for you as it was for me. That is then the end of the question. In the next session, I want us to look at one final example on the balls, and then we can get straight into graph questions. And then from there, we can do a few activities on graph questions, and we can then consolidate vertical projectile motion. But from me to you right now, at this point, I will see you in the next session. Goodbye.